Okay, so kita akan bincang jawapan untuk soalan revision chapter 1. Okay, matter ya. Jadi markah penuh untuk soalan tajuk matter ni ada 21. Okay, jadi kita tengok soalan nombor 1. Naturally occurring magnesium has 3 isotope, magnesium 24, magnesium 25 and magnesium 26, which are 78.6%, 10.1% and 11.3% relative abundant respectively. Sketch and label the expected mass spectrum of the magnesium. Okay, soalan pertama dia nak kita sketch the expected mass spectrum of magnesium for these 3 isotope. Number 2, if the average atomic mass of boron given for 10 boron and 11 boron is 10.8 U, what is the percentage of the lighter atom in the isotopic mass? Okay, jadi kita tengok jawapan nombor 1 ni kena sketch and label the expected mass of the magnesium. Jadi kita kena sketch ya. Jadi untuk y-axis adalah relative abundant dalam unit persen, dan untuk x-axis adalah mass over E ya, m over E. Dan kita akan sketch untuk 3 isotop for magnesium, 24, 25 and 26. Jadi 24 ni garis yang paling tinggi, so kena label lah ya, 78.6% abundant. Okay, dan kena ada scale ya, kena ada scale di sini. And then for 25 is 10.1% and magnesium 26 is 11.3%. So ada 2 markah. Markah untuk label X and Y axis 1 markah, dan juga 3 correct line with label 1 mark ya. Jadi kita lukis garis ni mesti tunjukkan yang 24 ni, magnesium 24 yang paling tinggi dia punya abundance dia. Okay, and then number 2, kita nak calculate what is the abundant for magnesium, bukan magnesium, boron 11. Jadi let the percent 10 boron is X and percent for 11 boron is 100 minus X ya. So this is insist, kena tulis assumption ni, and then kita gunakan formula summation of QIMI, average atomic mass ya, is equal to summation of QIMI over summation of QI. Then substitute into the formula, then end up kita akan dapat X is equal to 20%. So this is the abundant for boron 11 ya. So ada 2 markah. So markah yang pertama pada nilai yang kita masukkan dalam formula average atomic mass, and 1 mark pada markah 20% ya, value of 20%. Okay, so dekat sini dah total 4 markah. Okay, for question number 2, empirical formula. So given analysis of pure sample of compound A contain of 50.1% sulfur, 49.9% oxygen by mass, and determine the empirical formula for the compound A. So 3 marks ya. Okay, jadi first we assume the mass of the compound is 100 gram. So composition of sulfur is 50.1 gram and oxygen is 49.9 gram. Okay, then calculate the number of mole for each element, sulfur and oxygen, mass over molar mass. For sulfur is equal to 1.56 and oxygen is 3.12. Next, we calculate the simplest mole ratio, which is the smallest number is 1.56 yeah. So 1.56 divided by 1.56 is equal to 1, and for oxygen is 2. Alright, so the empirical formula of SO2 is 1 mark. Okay, so the mark allocate for this question is 2 mark. 2 mark for correct number of mole for each sulfur and oxygen, and another 1 mark is for simplest ratio, and another 1 mark is empirical formula SO2 yeah. So total is 3 marks. Sorry, this is 3 marks yeah. Okay, for question number 3, so this is balancing redox equation. Okay, 30 mil 0.025 molar sodium dichromate solution, titrate with ferrum sulfate, and then given the following redox equation, which is the titration require 40 ml ferrum sulfate to reach the end point. Okay, question number 1, balance the redox equation for the above fraction. Number 2, calculate the mass of sodium dichromate needed to prepare 0.025 molar solution in 50 ml volumetric flask. And number 3, determine the molarity of ferrum 2 plus solution. Okay, so number 1, how to balance the equation. So the first step, we separate into half equation, reduction and oxidation. So reduction 1 mark and oxidation is 1 mark. Okay, and then balance each half equation. Okay, for oxidation, so this is the equation, chromate ion plus 14 hydrogen plus 6 electron produce 2 Cr3 plus and 7 H2O. Okay, so for ferrum is oxidation. So ferrum 2 plus produce Fe3 plus E electron. So now we want to cancel out or eliminate the number of electron. So for ferrum 2 plus, we need multiply by 6, yeah. Okay, so 1 mark for half equation for reduction and reduction. Another 1 mark is balance, yeah, for each half equation. Okay, next we combine the both equation, and the last equation is chromate ion plus 6 ferrum 2 plus produce plus 14 hydrogen produce 2 Cr3 plus 6 ferrum 3 plus and 7 H2O. So the overall equation is 1 mark. Okay, and then number 2, calculate. Look at the question is calculate the mass of sodium dichromate needed to prepare the solution. So we calculate first the number of mole of sodium dichromate based on concentration and volume. So we got 1.25 times 10 to the power of negative 3 mole. So 1 mark for correct number of mole for sodium dichromate. And then calculate the mass of sodium dichromate, multiply the number of mole with the molar mass, 262.0 gram per mole, and then we got 0.33 grams. So mass of sodium dichromate needed to prepare the solution is 0.33 gram. Okay, so this step is 1 mark. Okay, number 3, calculate the molarity of ferrum 2 plus solution. So based on equation, 1 mole of chromate ion react with 6 mole of ferrum 2 plus. Okay, if 7.5 times 10 to the power of negative 4 mole chromate ion react with 6 times 7.5 times 10 to the power of negative 4 mole ferrum. So this is the number of mole for ferrum ion. Okay, so next we use formula. Molarity is equal to mole of solute divided by volume of solution. So mole of solute, mole of ferrum 2 plus is 4.5 times 10 to the power of negative 3. Okay, divide by the volume of solution, in unit liter, 40 times 10 to the power of negative 3 liters. So lastly we got 0.112 molar. Okay, so for this question, we allocate 4 mark. Okay, 1 mark for number of mole for dichromate ion. Next, another 1 mark is number of mole for ferrum 2 plus from the stoichiometry. And then 1 mark for the calculation of molarity. Okay, so last question for set 1. Okay, consider the following reaction. 2 mole nitrogen monoxide react with 2 mole of carbon monoxide, produce nitrogen gas, and 2 mole of carbon dioxide. If 300 gram of carbon monoxide has reacted, calculate the mass percentage of carbon dioxide in the mixture of the product, ya. So dia nak kita calculate the mass of carbon monoxide in the mixture of product. So product is nitrogen and carbon dioxide. Okay, so first we calculate the number of mole of carbon monoxide based on the mass given. So 300 gram divided by molar mass of carbon monoxide. So the number of mole for carbon monoxide is 10.71 mole. Okay, so 1 mark for correct number of mole of carbon carbon monoxide. So we calculate next, we calculate the number of mole for nitrogen. Yeah, so compare from the equation, 2 mole of nitrogen monoxide react with 2 mole of carbon monoxide and produce 1 mole of nitrogen and produce 2 mole of carbon dioxide. Okay, so 2 mole of carbon dioxide, we compare number of mole of carbon monoxide with 1 mole of nitrogen. Okay, if 10.71 mole of carbon monoxide reacted, so it produced 5.355 mole of nitrogen. Okay, so this is 1 mark for number of mole of nitrogen. Next, we calculate the number of mole of nitrogen gas. So equal to number of mole times molar mass. So equal to 149.94 grams. So 1 mark for mass of nitrogen. Okay, next we calculate the number of mole for carbon dioxide. Okay, so from equation, 2 mole carbon dioxide monoxide react with 2 mole of carbon dioxide. Yeah, so if 10.71 mole carbon monoxide equal to 10.71 mole carbon dioxide. So mass of carbon dioxide is equal to number of mole times molar mass of carbon monoxide. So equal to 471.24 grams. So 1 mark, another 1 mark for mass of carbon dioxide. Okay, next we want to calculate the mass composition of carbon dioxide. So equal to mass of carbon dioxide divided by mass of carbon dioxide plus mass of nitrogen. Okay, so equal to mass of carbon dioxide divided by the mass total, yeah, mass total, which is mass of carbon dioxide plus mass of nitrogen times 100. So equal to 79.92%. So this is another 1 mark. Yeah. So for question number 4, the mark allocate is 5 mark. Okay, next is question for set B. Given compound E is the hydrocarbon with formula CXHY and the mass of the hydrocarbon is 6.848 gram. And burn incompletely in pure oxygen to produce 21.5 gram of carbon dioxide and 8.87 gram of H2O. Determine the empirical formula of the compound E given the molar mass is 128.2 gram per mole, and determine the molecular formula of the compound. Okay, so this is the equation for the reaction of hydrocarbon E with oxygen to produce carbon dioxide and H2O. Okay, so first we need to calculate the mass of carbon from the mass of carbon dioxide produced. Okay, 1 mole of carbon dioxide is equal to 44.0 gram carbon dioxide. So this is the mass of 1 mole of carbon dioxide, and in 1 mole of carbon dioxide there is 1 atom of carbon, which is the mass is 12 gram. So next we calculate the mass of carbon by compare the mass of 1 atom of carbon with the mass of 1 mole of carbon dioxide. Okay, so 12 gram divided by 44.0 gram times 21.5 gram carbon dioxide produced. So the mass of carbon is 5.863 gram. Okay, so this is 1 mark for the calculation of mass of carbon. Okay, next is the mass of hydrogen. Yeah, we calculate from the mass of H2O produced, which is 1 mole of H2O equal to 8.0 gram of H2O. So this is the mass of 1 mole of H2O, and in 1 mole of H2O there are 2 atom of hydrogen, which is the mass is 2 gram. Okay, so the mass of hydrogen is equal to, compare the mass of two atom of hydrogen with mass of 1 mole of H2O. 2 gram divided by 18 gram times the mass of H2O produced, 8.87 grams. So equal to 0.985 gram. So this is the mass of hydrogen from the mass of H2O. So 1 mark for the correct value mass of hydrogen. Next, we want to calculate the empirical formula for the hydrocarbon. So the mass of carbon is 5.8663 gram. For hydrogen is 0.985 gram. So next, calculate the number of mole for carbon, mass over molar mass of carbon, so equal to 0.48998 gram, 98 mole, and the number of mole for hydrogen, mass over molar mass, is equal to 0.985. Okay, so correct for the both number of mole for carbon and hydrogen, 1 mark. Okay, next we calculate the simplest ratio, which is the smallest number is 0.489 mole. Okay, for the number of mole for carbon. So simplest ratio carbon is equal to 1, and for hydrogen is 2. Alright, so another 1 mark for the correct values, simplest ratio for carbon and hydrogen. Next, the empirical formula for the hydrocarbon is CH2. Okay, so another 1 mark. Okay, next we want to calculate the molecular formula. So from the empirical formula, CH2, the mass for the empirical formula is 14. Yeah, so we determine the value of N, which is the molar mass given 128.2 gram per mole divided by the molar mass of the empirical formula, 14.0 gram per mole, so equal to 9.2. So this is nearer to 9. Okay, so equal to 9. So the molecular formula for the compound is CH2 times 9, so equal to C9H18. Okay, so 1 mark for the value of N, and another 1 mark is the molecular formula. So total mark for this question is 7 mark. Okay, question number 2 is the concentration. Okay, calculate the mass of sodium hydroxide that need to be added to 150 gram of water to produce a solution with the molality 1.2 molar. So given the molality is 1.2. Okay, so first by using the formula of molality, which is N solute divide by mass of solvent in kilogram. Okay, so given molality 1.2 mole per kg, so equal to N solute divided by the mass of solvent. So the mass of solvent is water, yeah, convert into kg, 150 times 10 to the power of -3 kilogram. So 1 mark. For the substitute the value in the formula. So N solute, which is NaOH, is equal to 0.18 mole. So another 1 mark is for the number of mole of NaOH. Next, calculate the mass of NaOH needed. Number of mole of NaOH times the molar mass of NaOH. So 0.18 mole times 40 gram per mole. So this step contribute 1 mark, and last one we got 7.20 gram of mass NaOH needed. Yeah, so this is 1 mark. So altogether 4 mark for question number 2. Okay, number 3 is limiting reactant question. So vinyl chloride C2H3Cl prepared by the reaction of ethane gas C2H2 with hydrochloric acid. In the preparation of vinyl chloride, 70 gram of C2H2 is reacted with 102.0 gram of HCl. So given respectively mass of each reactant. Okay, question number 1, write the balanced chemical equation for the reaction. Number 2, identify the limiting reactant. Then number 3, calculate the mass of the product, which is mass of C2H2Cl. And number 4, calculate the mass of excess reactant. Okay, so this question we allocate 12 mark. 10 marks. Okay, 10 mark. Okay, so question number 1, balance chemical equation C2H2 plus HCl produce C2H3Cl. So write the balance equation, 1 mark. Okay, number 2, we want to determine the limiting reactant. So number 2, first we calculate the number of mole for C2H2, mass over molar mass is equal to 2.692 mole C2H2. So this is available number of mole for C2H2. Next, calculate the number of mole of HCl. Mass of HCl divide the molar mass of HCl. So mole of HCl is equal to 2.795 mole HCl. So this is the number of mole of HCl available. So both correct for number of mole of C2H2 and HCl. So 1 mark. Okay, next, from the equation, we compare from the equation, 1 mole of HCl react with 1 mole of C2H2. If 2.795 mole HCl available, react with 2.795 mole of C2H2, this is the number of mole of C2H2 needed for the reaction. Okay, so we compare from the number of mole of CH2 needed and the number of mole of C2H2 available. Yeah, so 2.795 mole C2H2 needed is smaller than the number of mole of C2H2 available, which is C2H2 is in limit. Okay, the C2H2 is the limiting reactant. Okay, so from question number 2 is 3 mark. 1 mark, we calculate the number of mole for C2H2 needed, and then we compare from the number of mole for C2H2 needed with the C2H2 available. Okay, and then another mark, the statement for C2H2 is limiting reactant. Okay, for question number 3, we want to calculate the mass of product. Okay, so compare from the reaction from the limiting reactant. So limiting reactant is C2H2. 1 mole of C2H2 produce 1 mole of C2H3Cl. Okay, if 2.692 mole of C2H2, okay, react with 2.692 mole of C2H3Cl produced. So this is the product. Okay, so mass of C2H2Cl is equal to number of mole times molar mass. Okay, mole times molar mass. So the mass of C2H3Cl produced is 168.25 grams. So question number 3 is 3 mark, 1 mark. For the number of mole for C2H3Cl. Okay, another 1 mark. Number of mole times molar mass, and the third mark is for the correct mass of C2H3Cl. Okay, question number 4, calculate the mass of HCl produced, which is HCl is the excess reactant. Okay, so compare from the equation 1 mole of C2H2 limiting reactant react with 1 mole of HCl. Okay, if 2.692 mole C2H2, so this is the number of mole for C2H2 available, react with 2.692 mole of HCl, this is the number of mole of HCl reacted. Okay, so the number of mole of HCl remain after the reaction is equal to mole available minus mole needed or mole reacted. So 2.795 minus 2.692 mole, so 0.103 mole. So this is the number of mole of HCl remain after the reaction complete. Okay, next, calculate the mass of HCl, which is mass times molar mass. So equal to 3.76 gram. Okay, so for question number 4, 2 mark, 1 mole for the correct number of mole for HCl remain, and another 1 mark is the mass of excess HCl, 3.76 gram.